Hello all, my name is Anand Ranjan. I am assistant professor in the School of Computer Application, Babu Banarsi Das University, Lucknow. In today's video lecture, we are going to discuss about the fundamental things related to digital electronics. Especially, we will discuss the MINTERM and MAXTERM approach. Digital electronics. So during this video lecture series, we will discuss about the different aspects of digital electronics related to the basic Boolean algebra concept, number systems, and so on. So first of all we start with the digital system concept. Okay. So we have the two options. Means we have digital system, and these digital systems could be used with the number 0 to 9 or 0 and 1. So when we have the digital system with only two signal, we can say at this time, then this system is known as the binary digital system. Okay. So in when we say binary digital system, then in compared to the real world problem, which is in English, first of all we need to convert it into the binary, so that with the help of binary digital system we can do these things. So now we have real world problem, which is quite normally in English need to be converted into binary digital system. And for this conversion, means in here we have real world problem is in English, and the binary digital systems are in the form of 0 and 1. And this for this conversion we actually required one truth table. Okay. So let us discuss one example. For example, a number n ranges from 0 to 3. Find out if n is even or odd. If n is even, then output is equal to 1. If n is odd, then output is equal to 0. So this is our real world problem. What we can say, this is in English, which need to be converted into the digital form with the use of truth table. Okay. So let's formulate this into the digital domain. So for this, let us have one table where we will write the number 0, 1, 2 and 3. We choose variable x and y, and this represents the function f. So with the two variable we can produce four different combination with 2 raised to the power 4 in digital domain. So this will be given as 0 0 0 1 1 0 and 1 1. And as this problem says, depending upon the even and odd condition, the output we suggest 1 or 0. So accordingly, here what we can write in case of this 0, which is treated as the even number represented by the two variable by the combination 0 0, we will mark the output as 1. Similarly, the 2, this is even, this for, and this is 2, which is again the even number, the combination represented by the variable x and y, which is 1 and 0, again the output as per the statement given above is given as 1, while the odd cases, which is represented by the combination 0 1 and 1 1, will be 0. Okay. So this is the complete truth table. This is the truth table to represent the real world problem, which is in English, into the first step towards to make this in digital domain. So here the one min-term design and max-term design concept comes into the picture. But before that, let's make a block diagram of binary digital system in which inputs are x and y and your output is represented by f. So this is your binary digital system. So now you can see that the above this English statements converted into a binary digital system with the help of this truth table diagram, where x and y are the variables and f represents the function. There are two approaches actually for implementing this binary digital system. These approaches are related to the min-term design or max-term design. Means if we talk about the min-terms design, then we have to concentrate on 1 at the output, and if we are talking about the max term design, then we have to look forward the 0 at the output. Okay, so we, with the help of different logic gate, we are having, means we are having the different logic gates like NOT gate, AND gate, OR gate, NAND gate, NOR gate, XOR gate, XNOR gate. So with the help of these logic gates, we can able to implement this binary digital system. Okay, so let us continue our discussion with the min-term and max-term approach in designing the binary digital system. So first of all, we will start with the min-term approach of designing a binary system. Okay, so Let us draw one block diagram here. One block diagram here. This is the binary digital system BDS. Here the input are x and y. The output is represented by the function f. And for this, let us draw one truth table x, y, and f. And for with this variable input x and y, we have the combination 0 0 0 1 1 0 1 1. Let us consider the previous case, even and odd problem. We write here the output as 1 here in case of even, and in case of odd we represent the function output 0. So this, just we told, we have to concentrate on 1 at the output. For this we have to write the function for the output once only. So in this case we have f is equal to x bar, y bar. This is the first combination 0 0 1, and second combination is x y bar, x y bar. So these two terms are at the output is represented by 1, and these two outputs are getting OR together because both the outputs are there in the output. So this is OR together. Okay. So in this expression, what we can say, the first term, this is the first term which is represented small m0, and this is represented by m2, and this operation OR is actually putting together these two terms, and this is the min-term expression representing the problem of even and odd problem in a mathematical or in a logical form, in a Boolean expression form we can say. Okay, so what we can summarize here, that this expression is known as min-term, min-terms obtained by ANDed all the variables of the function in such a way that bit 0 is complemented variable and bit 1 represent the uncomplemented variable. Okay. Also represents as small I mi, where I is the decimal equivalent of of the binary input. Okay, shorthand representation we can say. And another point what we can say, this is sum of maxterm form. Sum of, sorry, minterm, sum of minterms form. Okay, it's not actually a, so we will discuss. Also represented as f is equal to m0 plus m2, or f is equal to, with summation symbol, 0 comma 2. Okay, to conclude this, let's take one note, because some might have confused with the SOP and sum of minterms. So let me write this note point here. After simplify the sum of minterm from minterms form, we will get the sum of product form. We will get the sum of product form. So sum of product form is nothing but the simplification of this sum of minterm expressions. Okay, all right. So let us now talk about the approach for maxterm. The maxterm approach of designing a binary digital system. Okay, maxterm approach for of designing the binary digital system. Again, we are taking the same example with the two variable x and y and the output function represented by 0. With this we have combination 0 0 0 1 1 0 1 1. The even and out conditions means 1 here for the even and 0 for the odd combination. So now we are going to write the function for 0 this time. We are focusing on 0 this time, and for writing the function for 0, let us write this in this way: f is equal to x plus y bar. This will be the first term with this combination, and the second term is for this combination, means the last one, which is x bar plus y bar. Okay, and these two terms are getting ANDed together. So now in this expression, the first term is represented by the max term with capital M1 Second term is represented by the max term capital M3, and this is here the AND operation performed between these two terms. So what we can conclude with is this is known as max term, known as max term obtained by ORing, obtained by ORing all the variable, all the variable, all the variable all the variables of the function in such a way, way that that bit 0 represents uncomplemented variable, while bit 1 represents the complemented variable. Okay, and also represent as capital MJ, where J is decimal equivalent of binary input. Okay, and this expression can also be called as the product of max terms. Okay, and also represent as f is equal to capital M1 and M3, or f is equal to pi 1 comma 3. So let us again take the important note point, which will give you the idea what is the difference between the sum of product and product of max term. Means after simplification of this product of max term expression, we get product of sum, or the POS form of the binary digital system. Okay, so let us write this important note point here. Therefore the sum of minterm and the product of max term represent represent the unsimplified form of Boolean expression. Boolean expression. Upon simplification, upon simplification, upon simplification, they give the sum of product and the product of sum form. Okay, all right. So now let us talk about the fundamental aspect of the variable, literals and terms. Okay, so that will be continue in our next video. We will discuss in detail about the what are variable, what are literal, what are terms, and we also talk about the relation between the min term and max term. Okay.